All right, so our cation is Mn4 plus. We're going to write Mn4 plus. And then we're going to be reacting that. So plus. And then our anion is oxygen's most common ion. So I want you guys to take a second, go on the periodic table and figure out oxygen's MCI and see if you can balance that equation out and find the ionic compound they make. So I'll give you guys about 2 minutes to do that, and then we'll go over it and then move on to the new material. Okay, so oxygen's MCI is going to be 2 minus. All right, so what we're going to do is we got to balance out the charges. So if you take a look at this equation, we have way too much positive energy, right? So we only need 1 Mn, and we're going to need 2 oxygens to balance out the charges. Okay, so the chemical that we're going to make, ionic compound, is MnO2, and just put a 1 in the front. Okay. All right, and that's pretty much it. So again, for chemical equations, it's got to look exactly like that. If you weren't able to get exactly that, all the elements, all the numbers in the correct order, just make sure that you find out why. Because again, if it's not in that order, then it's going to be incorrect. Okay. Any questions? It's too early for this, right? Yep, I agree. Woke up this morning and I was like, I don't want to teach chem. All right, so let's move on to the new material since none of us are ready for it. Okay, so you guys do not need to write this down. I'm just going to go over this real quick as a refresher. We've already learned this. We talked about the difference between atoms, elements, and molecules. So atoms and elements, it's basically just the individual elements, right? So you go on the periodic table, you see carbon, you see nitrogen, you see oxygen. We call those things atoms or elements, pretty much the same thing. Okay. Now, molecules, on the other hand, are when you put elements together, right? And you make a bigger structure. And so we learned how to write different formulas like that. Okay, now we're going to talk about very briefly how to interpret molecule formulas. And so let's write down number 1. I want you guys to write number 1 and just write down this chemical formula. Number 1 is H2O. And on your paper, I just want you to write down how many of each element are in H2O. Yeah, I think we did this in like the first day of class in that article that you guys read. So it shouldn't be too bad. But I want you guys just to write down how many of each element are in H2O. All right, so hopefully you guys got 2 hydrogen and 1 oxygen. Everybody good with that answer? Okay. So again, I just wanted to go over the point that this number in the back applies to the element in the front. And if there is no number, it just means there's 1 of it. So that's why we got 2 hydrogens, 1 oxygen. Okay. All right, number 2, you guys don't need to write down. Just mentally, just kind of figure this out. Let's go over them, I guess, verbally. How many carbons do we have in cocaine? Yeah, 17. So there's 17 carbons in cocaine. How many hydrogens? Yeah, 21. How many nitrogens? 1. And we got 4 oxygens. Okay, so that's how many elements there are inside of this compound right here. Okay, so it should be pretty easy by now. I want you guys to try number 3 with the person next to you. I'll give you guys about a minute. See if you guys can jot that down on your notes. Write down how many of each element are in vinegar. You got vinegar's formula right there. All right, so I want you guys to show me with your fingers how many carbons are there inside of vinegar. I only see like 3 fingers. How many carbons are in vinegar? Yeah, it should be 2. Okay. And if you guys notice, there's a carbon here and there's a carbon here. They're split up, but they're still 2. Okay, so just keep that in mind. Sometimes when you're reading these molecule formulas, they'll split up the elements. We'll talk about why later. It's because this type of formula, it tells you what the molecule actually looks like. There's a carbon on the left side. There's a carbon in the middle. That's why it's like that. Okay, let's go to hydrogen next. Can you guys show me with your fingers how many hydrogens there are? How many hydrogens? Yeah, there's 3 right here and 1 at the very end. So you should have gotten 4. Okay. And then lastly, can you show me how many oxygens are there? Yeah, there's gonna be 2. 1, 2. Okay. So just be aware, sometimes you will get chemical formulas that look like that. Again, all you need to do is go and count how many elements there are. Okay. All right. Any questions about how to count the elements? Well, it's not too bad. All right. So that's the types of chemical or molecule formulas we've been looking at so far. However, they do kind of get a little bit more ugly. And so let's scroll down and I'll show you guys what I mean by that. Okay. So a lot of times you'll get these parentheses inside of these molecule formulas. Okay, and these are really, really easy to interpret, even though they look kind of ugly. But it does make the number tracking a little bit harder. Okay, so whenever you have these formulas, all you need to remember is that you just multiply whatever's inside the parentheses by the number that's on the outside. Okay, so you just multiply everything inside by the number that's on the outside. Every time that there's parentheses, there should be a number behind it. And all you have to do is multiply everything inside by that number on the outside, okay? So just to show you guys what I mean by that, we got C9. So there's 9 carbons inside the parentheses, right? So that means that in total, estrogen is going to have 18 carbons. Again, it's because there's 9 on the inside of the parentheses, but we just multiply by the number on the outside. Okay. And then for hydrogen, there's 12 on the inside, but we just need to multiply that by the 2 on the outside. So there's going to be 24. And then if you look inside, there's only 1 oxygen because there's no number behind it. And so there's going to be a total of 2 oxygens. Okay, so that's how parentheses work. We will be using parentheses today, and going forward, you'll have to be pretty comfortable working with the parentheses. Just know the parentheses just mean you have multiple of everything on the inside. Okay. All right, so I'll give you guys about a minute. See if you guys can do number 5 with the person next to you. This time, the other human sex hormone, testosterone. I want you guys to figure out how many of each element there are inside of testosterone using this formula. Okay, so take a minute to do that, and then we'll go over it together. Alrighty, guys, so let's count up how many of each element we have. So if you take a look inside the parentheses, there's 9 carbon again, right? But there's a 2 on the outside, so we multiply by 2. That gives us 18. But if you look on the outside, there's 1 carbon hanging out by itself, right? So you should have a total of 19 carbons. Okay. All right, if you look inside the parentheses, there's a hydrogen with 14. But we multiply that by 2. So you should get a total of 28. Okay, and then lastly, we got an oxygen by itself again. Multiply that by 2. And you should get 2 oxygens. Okay, that's pretty much it. Hopefully parentheses aren't too bad. Any questions on these 2 problems? Okay, because you'll have to use these parentheses in just a second. Okay, so if not, let's move on. So what we're going to do now is we're going to use these parentheses with ions. So we'll be writing these ionic compound formulas, but we'll need these parentheses going forward. Okay, and the reason why is because so far we've looked at things called monatomic ions. You guys don't need to write this. Monatomic ions are ions that only have 1 atom. So if you look on the periodic table, we talked about how to find MCI, right? Or I give you something like Mn4+, like in the warm-up. Okay, those are called monatomic because there's only mono atoms. There's only 1 atom. However, today, we're going to be learning about something called polyatomic ions. I do need you guys to write this down. And polyatomic ions are molecules that have a charge. Okay? They're molecules that have a charge. So it's a group of atoms. You put them together, and then they have their own charge. And while you guys copy that down, I'm going to pass out a little handout that has the polyatomics we'll need to use for this class. All right, so I'm going to pull up the polyatomic ions sheet. So if you guys take a look at the handout you got, you guys can hold on to those. It should look something like this. Okay, and so I'm gonna show you guys what these polyatomic ions are real quick, and then we'll go into like the last practice problems for today. Okay, so polyatomic ions, like we said, they're molecules that have a charge. So up until this point, we've been looking at when only one element has a charge. However, when these molecules, these elements come together in this form, this molecule likes to have a charge too. Okay, and so they act the exact same way as regular ions. The only difference is you cannot change anything about these. Okay, you got to keep them exactly the way that they're written. Okay, so that's my big thing for you guys to remember. When we are working with polyatomic ions, don't change anything about these ions. Okay, they're perfect just the way they are. If you change it, you're messing up the ion and your formula will be incorrect. Okay, but other than that, the problems will look pretty similar to what we've been learning. So we're going to do 2 practice problems, and then we'll be all done for today, okay? All right, so we're going to be writing the chemical equation for the reaction between these ions. So let's start with the first one. So we start with Ca2+, okay? And it's going to be reacting with nitrate. So I want you guys to go on that new half sheet that you just got, and I want you guys to write down the formula for nitrate, okay? All right, so if you take a look at the polyatomic chart, you should see nitrate right here on the top right, okay? So if you look, nitrate is NO3-. So like I said, you want to keep it exactly the way it is. So for nitrate, we're just going to write NO3-, okay? All right, so from there, this looks pretty much what we've been doing, right? So do we have more positive or negative energy right now? Positive, right? Because positive 2. So how many nitrates do we need to balance it out? 2. That's it. It's the exact same thing we've been doing. The only difference is instead of an periodic table element, we got a polyatomic ion. And you'll need 1 calcium. Okay. All right, everybody good with that so far? Okay. And you guys don't need to memorize that polyatomic chart on your test. It'll be there for you. Okay, so you just need to know how to use it. All right, and then these guys are going to combine. So same thing as before. We're just going to put them right next to each other. We got Ca, and then we're going to put nitrate next to it. But if you guys remember, we need 2 nitrates. Okay, and this is where the parentheses are going to come into play. Since we need 2 of this entire thing right here, we're going to put parentheses around nitrate and put a 2 behind it. Okay? And so that's why we went over the parentheses thing. Okay, to show that we need 2 nitrates to balance out 1 calcium. All right. So again, since it is a chemical equation, it needs to look exactly like that. If anything's shifted, it's incorrect, especially when it comes to these parentheses. So just make sure you're aware of that, all right? Okay, let's do one last problem together before I get you guys started on your assignment. I want you guys to try number 2. These are both polyatomics. So see if you guys can do that with your neighbor. Take about 2-3 minutes, and then we'll go over it together. Okay, so for number 2, you guys got 2 polyatomics. So let's start with ammonium. So if you go to the polyatomic chart, ammonium is going to be NH4+. Okay, so we're going to write NH4+. And then for phosphate, we're going to go to the table again. And phosphate, you should get PO43-. Now be careful because there's phosphate and phosphite. It could be a little bit confusing. So just make sure you pick the one that's PO4. Okay. If you did phosphite by accident, it's okay. That's why we're going over these practice problems. If you look at the names, some of them are really similar, like sulfate, sulfite, nitrate, nitrite, right? So just be careful that you're careful with the endings, okay? So phosphate is going to be PO4 3 minus. Alrighty, so if we take a look at this, obviously we have way too much negative energy, right? So we got to balance it out with some positives. You're going to need 3 ammoniums and you'll need 1 phosphate. All right, same thing as before. We want to write the formulas exactly the way they are. So we got NH4 and PO4, but this time we're going to put the parentheses around NH4 because we need 3 of those. So this is what your formula should look like. And then we just put a 1 in the front. So I know these parentheses might get a little bit confusing. So during your assignment, make sure you come check with me so I can help you out if you need the help. But your formula, again, should look exactly like that. It should be in that order. Parentheses, NH4, parentheses 3, PO4. Okay.